number 1 is 8 teachers, 20 students, 5-person subcommittee. So if that, I gave you that, it would be a plain old perm com question. But I'm saying determine the probability that there are exactly 2 teachers. So you have to do that. After the word probability affects only the top. And then number 2 we'll do after that. So try this one out. That's because you're talking the whole time. So there's that. All right. We have 8 teachers, 20 students, 5-person subcommittee. That affects the top and the bottom, but mainly the bottom. And then after the word determine the probability, after this, affects the top. There are exactly 2 teachers. So I need a 5-person subcommittee. Do these people have jobs?
Yes.
No.
No.
That's just actually 8 of them do. They're teachers.
No, she's talking about the 5 people.
So it's going to be a C on the top and on the bottom because they don't have jobs. It's going to be a combination. That's permutation. Permutation order matters. Combination order doesn't matter. So we're going to have a C. Now we need to choose at least 2 teachers on the top. So I'm going to choose 2 teachers. Sorry, exactly 2 teachers. From how many?
28. No, teachers? 8.
8. What's my problem though? I need a what person subcommittee on the top and the bottom? 5. Currently I have how many on the top? 2. So I need 3 more. And they're going to have to be what?
Students.
Students, because I need to have exactly 2 teachers, so I can't have any more. Do I multiply them or add them? Multiply, why? And you need 2 teachers and 3 students. Then the bottom is everything before the word probability, correct? So, how many teachers and students are there? 28. And I have to choose how many? 5. So that's how we do that one. And then you'll just type the top in separately, write it as a number, equals over the bottom separate. And then you can reduce the fraction. Okay? Number 2. Number 2 has 2 questions, totally different questions here. So number 2 says, a bag of marbles has 5 green, 7 purple, and 3 blue. Okay? Question 1. A, or 2A has 1 marble being chosen. The probability it's green or purple. People will call me over and they'll say, did you replace the marble? There's only 1 marble.
Oh.
It's with or without replacement when you take out a marble and then take out another marble, right? You have to take out 2 in order to decide if you replace the first one or not. So that's not a question here. This one has the word or. So I'm going to do probability of green or purple. Then I go to my formula sheet over here, green or purple. Or is the top 2 formulas, correct?
Yeah.
The top 2 formulas for or are mutually exclusive or not mutually exclusive. Mutually exclusive means they have nothing in common. Not mutually exclusive means there's overlap and I have to subtract it off, right? So when it goes to or, I go to these 2 formulas on my formula sheet and I say, which one do I need to use? Well, is there a green and purple marble in this bag?
No.
No. So is there overlap?
No.
No. So these 2 are completely mutually exclusive. So I use the one without the subtraction, right? So I'm just going to add their 2 probabilities.
Or was times.
Nope.
Oh my god.
Exactly.
Probability of green plus the probability of purple. And if you forget, Juliana, look at the formula sheet. It has a plus sign, right? Okay. So we do probability of green plus the probability of purple. So probability of green is how many? 5 out of how many? 15 plus probability of purple. How many purples are there? 7 out of 15. So when you do ORs, your total is going to be out of the total. The total's not going to change, right? It's going to be out of 15 and the next time it's going to be out of 15 because you start off with full new probabilities each time when it's an OR. So we're going to get 12 out of 15, which reduces to 4 out of 5. Or if I said to the nearest 10, you would say 0.8. If I said to the nearest whole percent, you would say 80%. So it just depends on which one I asked. Okay?
That's pretty good.
Yeah. So we have 2 marbles. Now I'm taking out 1 marble and then another. So the question you have to ask is, are you replacing them or not? The only time you don't have to ask that question is if they're coming from out of 2 separate bags, right? If I had 1 bag and I was taking out a marble and another bag, I was taking a different marble out of it, it wouldn't matter if I held onto this one. This one's coming out of a completely different bag of marbles, right? Where this is 1 bag of marbles. So it says, I'm taking 2 marbles out without replacement. The probability of green and purple. So now I have to go to the AND formula. I have 2 AND formulas. The AND formulas are independent or dependent. So when I use a spinner, I roll a dice, I flip a coin, anything like that, or I replace the marble, they would be independent of each other, right? Because I'd be starting over with all of the same amount again if I replaced it. Without replacement, it's dependent, which is the second formula. Okay? So if you want to actually do the formula properly, because it says without replacement, you're still going to multiply your probability. So you're going to do probability of green times, because it's and, the probability of purple, but we do this /G. And what the heck does that straight up and down line G mean? It means the probability of purple given that I'm holding a green in my hand. That's what that means. Probability of purple given that I'm holding a green. Because that changes my probability if I'm holding a green, right? So probability of green is 5 out of 15. That doesn't change. Probability of purple given that I'm holding a green? What's that? 7 out of 14, because the total gets changed, right? Which is 35 out of, what's 15 times 14? 2, 10? And then what does that reduce to?
1/6.
Okay? Difference between 1 marble and an OR. We go to the mutually exclusive or not mutually exclusive. 2 marbles and an and. We go to the independent, dependent. The bottom 2 formulas, right? So we really have to look for that word and or, and we have to look for is 1 event happening, then it's or. 2 events happening, then it's this one and this one happening. Okay? You guys try this one. So the probability, goes with our conversation earlier, the probability of Jen not crashing her vehicle every day. I picked a name of someone I don't know, because I don't know any Jens this year. So we're not going to base this on your mother. Probability of Jen not crashing her vehicle every day is 0.95. Determine the probability of Jen not crashing the next 2 days, Jen crashing the next 2 days, Jen crashing on the first day, and not crashing on the second. So if I give you not crashing, you can get the probability of its complement, which is crashing very easily, right? What do complement and the normal one add up to? 1 when I give you a decimal. If I give you a percent, they'd add up to 100. So we know the probability of not crashing is 0.95. And then I can quickly find the probability of crashing, which is 0.05. You try and answer the question. So if it says Jen not crashing the next 2 days, that means the probability of not crashing, is it not crashing and not crashing, or not crashing and or not crashing? And. So we go probability of not crashing the first day and probability of not crashing the second day, which is 0.95 times 0.95, which is 0 decimal. Is it 9?
9025.
9025. Then it says Jen crashing the next 2 days. So you would do probability of crashing times probability of crashing, which is 0.05 times 0.05, which is 0. I don't remember what it is.
0.0025.
Is it really that?
That could be wrong.
No, I think you're right.
I'm crashing.
I think you're correct. Jen crashing on the first day and not crashing on the second. So probability of crashing and the probability of not crashing. So crashing is 0.05 times 0.95. And what do we get? 0.0475. Okay. Now we're going to the simplification sheets. So we're going to do the simplifying one first. And we'll get to where we get to. Okay. Quiet, please. So for the first one, it says simplify the following and state restrictions on the variable. So we have to simplify the whole thing. I only made you do restrictions just for practice, but you actually have to simplify the whole thing. So the top, we're going to have to, we can take out a 6 and a x, and then we're left with x plus 4. On the bottom, we have a 6 and an x. Our NPVs are going to be x cannot equal 0. Now, can I cancel anything off? What? The x and the 6. So I'm left with just x plus 4 over 1. Do I have to write the 1 if it's in the denominator? No. Do I have to write the 1 if it's in the numerator? Yes.
Can you write it anyways?
Yep, you can write it. No, you won't, but if it's a multiple choice, it just won't be there as an option. But if it was a numeric response and you left it, you'd be fine. For B, I have 14 and a squared. So I'm just going to write 14 and a and a. In the bottom, what can I take out? A 7 and a a. I put in separate brackets. When I take 7a out of 21a, I'm left with 3 minus 28a squared. Take out 7a. 4a. So when I go to do my NPVs, 7 doesn't get me anything. I have a cannot equal 0, and I have 3 minus 4a cannot equal 0. Subtract the 3. Negative 4a cannot equal negative 3. Then I divide by negative 4. A cannot equal 3/4. Can I cancel anything off?
Yes.
What? The A's. And the 14 and 7 are in brackets by themselves, so I can take a 7 out of both. 7 divided by 7 is 1. 14 divided by 7 is 2. So on the top, I'm left with 2a over 3 minus 4a. And I have to say a cannot equal 0 and 3/4. C, what can I take out of the top?
3x.
A 3x. I can put them in their own brackets. When I take a 3x out of 3x squared, I'm left with x plus, what's 15x take out of 3x? 5. Over 6x squared minus 3x, I can take out a 3x. And then 6x squared, take out 3x, I'm left with 2x minus 1. Okay. So when I go to state non-permissible values, the 3 doesn't get me anything. The x becomes x cannot equal 0. 2x minus 1 cannot equal 0. Add my 1 over. 2x cannot equal 1. Divide by 2. X cannot equal a half. So there's my two NPVs. I can cross off the 3's and the x's. And I'm left with x plus 5 over 2x minus 1. Do I need to write them in brackets like this for the answer? No. But it's not wrong if you do it. Put your phones away. All right, D, what can I do? What can I do with D?
Take a 3M.
A 3M. You guys are in slow-mo. 3M cubed. So I can write 3M cubed, or I could write 3MMM if I really want to. And then when you take a 3M cubed out of 9M cubed, you get 3 plus 5M over 6M squared, which I can write as MM. 6. Yummy. Okay, NPVs. I just have M can't equal 0 because the 6 gets me nothing, right? These are the best NPVs ever. So M and M cancel, M and M cancel, and then the 3 and the 6 are by themselves, so the 6 divided by 3 is 2, 3 divided by 3 is 1, so I'm left with M, 3 plus 5M over 2. Stop talking. M cannot equal 0. For E,
X cannot equal the NPVs. Would it be wrong since it's not the actual variable?
yeah, it will be wrong. Sad, hey? Okay, E, what can I take out? An 8 and a X. Then I'm left with X minus 2. The bottom I can take out a 4 and an X, and I'm left with X plus 9. So my NPVs, my non-permissible values are my restrictions. 4 gets me nothing. X gets me X cannot equal 0. X plus 9 cannot equal 0. Subtract 9. X cannot equal negative 9 is my other one. The X's cancel. 4 divided by 4 is 1. 8 divided by 4 is 2. So I'm going to get 2x minus 2 over x plus 9. X cannot equal 0 or negative 9. And then F, what can I take out of F? A 4 and a squared. So I can go 4a and a. When I take 4a squared out of 12a squared, I'm left with 3. Minus 8 divided by 4 is 2. A cubed taking a squared out, I'm left with a. Over, I can take a 2a out. 2a out of 14a is 7. Minus 2a out of 2a squared is an a. So when I go to do my NPVs, I'm going to get a cannot equal 0. And I'm going to get 7 minus a cannot equal 0, and I can just add the a over. 7 cannot equal a. What can cancel? Some a's. An a for an a. And then the 4 and the 2 I can take up. 2. 4 divided by 2 is 2. 2 divided by 2 is 1. So on the top I'm left with 2a, 3 minus 2a, over 7 minus a. A cannot equal 0 and 7. Can you wipe off your